The strangest thing about a Starship space station is that it would begin as a rocket, not a clean orbital habitat, not a carefully assembled laboratory. A pressurized steel tower, launched on fire, shaking under millions of pounds of thrust, built first to survive violence before it can ever become a home. That is the contradiction at the center of this idea. SpaceX is building Starship to move enormous mass beyond Earth. Moon cargo, Mars hardware, satellites, fuel, people. But hidden inside that ambition is a simpler, colder possibility. If you can place a 9-meter-wide spacecraft in orbit and leave it there, you have already launched the hardest part of a space station, the shell. For decades, space stations have been built like ships in bottles. Small modules, narrow hatches, years of assembly. Every wall, rack, pipe wire, and sleeping compartment constrained by the shape of the rocket that carried it. The International Space Station is one of the greatest machines ever made, but inside it is still a place where human beings live inside corridors. Starship changes the geometry. Its upper stage is not just a spacecraft. It is a volume problem solved violently. A single structure large enough to make older station modules feel like tunnels. And if that structure no longer needs to land, no longer needs heat tiles, flaps, or Mars-bound propellant tanks, then its purpose begins to shift. A vehicle becomes architecture. But this is where the dream becomes harder. Because launching empty space is not the same as making it livable. Orbit does not forgive unfinished work. A station needs power, cooling air, water, shielding, docking, waste systems, fire control, escape plans, and a way to keep human bodies from quietly breaking down. So the real question is not whether Starship is big enough. The real question is, what has to be sacrificed to turn a rocket into a place where people can survive? The easy version of this story is that SpaceX launches a Starship, empties the tanks, installs some windows, and suddenly humanity has a giant orbital hotel. That version is comforting. It treats space like real estate. Find a big enough room, decorate it, invite people inside. But orbit is not a location in the normal sense. It is a fall that never ends. Everything inside that falling structure has to keep working while moving faster than a rifle bullet, passing from sunlight into darkness again and again, every 90 minutes. A space station is not valuable because it is large. It is valuable because it does not kill you. This is what people usually miss. The International Space Station looks cramped because it had to be built from pieces. But those pieces are not just metal tubes. They are life support systems, laboratories, pressure vessels, power networks, cooling loops, guidance computers, airlocks, storage rooms, emergency shelters, and escape routes, all joined together in a place where a missing seal can become a disaster. Starship's size solves one problem and exposes several others. A wider hull gives you volume. It gives you freedom. It gives designers the possibility of decks, rooms, open communal areas, and a station that no longer feels like a submarine. But volume also demands more air, more filtration, more insulation, more wiring, more fire detection, more thermal control, and more ways for something small to become unreachable. On Earth, a broken pump is an inconvenience. In orbit, it can become a countdown. So the myth is not that Starship could become a space station. That part is plausible. The myth is that size makes the problem easy. Because the moment Starship stops being a rocket, it inherits a different burden. It must become a machine that protects fragile bodies from an environment that never gets tired. The first wall is not comfort. It is construction. A Starship space station would probably launch mostly as a sealed structure, not a finished home. The outer hull could be prepared on Earth. Some decks, plumbing cables, and pressure systems could be installed before flight. But the deepest transformation happens after orbit, when the rocket is already beyond reach of ordinary hands. That changes everything. On Earth, you build with gravity. Tools stay where you put them. Dust falls down. Fluids settle. Workers stand on floors. In orbit, nothing behaves politely. A bolt drifts away. A cable refuses to hang. A drop of liquid becomes a wandering sphere. Even the idea of up and down becomes a design decision. Now take the lower section of Starship. That space was built around propellant, methane and oxygen, tanks, plumbing valves, structural supports, insulation engine hardware. To turn that region into part of a station, you do not simply clean it and move in. You need to isolate, convert, reinforce, or remove systems that were designed for launch, not habitation. And this work would happen inside a machine still circling Earth at orbital speed. Robots could help. Future autonomous systems could cut, inspect, weld root cables, and install internal equipment. But space construction is not just construction with better tools. It is construction where every mistake creates debris, contamination leaks, or fire risk in a sealed habitat. A normal building can survive delay. A station cannot survive confusion. Before anyone sleeps there, the station must prove that air stays inside. Heat can leave water, can be recovered. Power can flow, and emergencies can be contained. The empty volume is only potential. The first real challenge is turning that potential into a machine precise enough to trust with breathing. The deeper system is not the hull. It is the loop. A station survives by trapping what Earth gives away for free. Air cannot be wasted. Water cannot be wasted. Heat cannot be ignored. Carbon dioxide cannot simply disappear because people keep breathing it out. Every human on board is a small chemical engine. You consume oxygen. You release moisture. You shed skin. You create waste. You heat the room around you. On Earth, the atmosphere swallows most of this without asking. In orbit, the station has to become the atmosphere, the plumbing, the sewer, the power grid, and the weather. This is why the old propellant tank space matters. It may not become beautiful living space. It may become something more important. A mechanical basement, a hidden organ system, water processors, oxygen generation, battery storage, carbon dioxide removal, waste handling, pumps, valves, filters, tanks, and machines that nobody thinks about until one of them fails. And then there is heat. Space is freezing in one direction and burning in another. Sunlight can roast the exposed skin of a spacecraft, while shadow can drain warmth away. But inside the station, electronics, humans, lights, computers, and life support constantly produce heat. You cannot open a window. You cannot let warm air drift outside. You have to collect heat and reject it through radiators. That means a Starship station needs not just solar arrays, but a thermal nervous system spread through the vehicle, moving heat away from the living volume and bleeding it into the blackness. And above all of it sits radiation. Most of the time, Earth's magnetic field helps, but it is not armor. A solar storm can turn the sky into a threat. Water supplies and structure may need to form a shelter, a small protected room, where the crew waits while the sun throws particles across space. The station is not a place. It is a bargain with physics. And physics always collects. If Starship becomes a space station, the consequence is not just more room. It changes what orbit is for. For most of the space age, living in orbit has meant accepting limits. Small crews, tight schedules, narrow labs, every kilogram negotiated before launch. Every experiment designed around scarcity. The station was never just a destination. It was a compromise held together by planning patience and machines that could not be allowed to fail. A Starship station would not erase those limits, but it would move the boundary. With more internal volume, crews could separate work from rest. Laboratories could expand. Private companies could test manufacturing processes that only work in microgravity. Researchers could grow material, study biology, run long-duration human health experiments, and build systems meant for deeper space without pretending that 3 people in a tube is the final shape of civilization. But the same scale that makes it exciting also makes it unforgiving. A larger station needs more supplies, more maintenance, more docking traffic, more spare parts. More people trained to respond when something stops working at the worst possible time. The station becomes less like a spacecraft and more like a small city whose entire atmosphere is manufactured. And cities have hidden costs. They require governance, scheduling, rules, medical systems, fire procedures, privacy, conflict management. A way to decide who gets to go, who gets to stay, and who pays for the oxygen everyone is breathing. That is the part nobody sees in the renderings. The beautiful windows come last. Before them comes the logistics chain, the launch cadence, the cargo manifests, the insurance, the inspections, the uncomfortable fact that a space station is not built once. It is rebuilt every day by replacement parts maintenance work and people who do not have the luxury of being careless. This is why a Starship station matters. Not because it would make space easy. Because it would reveal whether humanity can operate at a new scale without lying to itself about what that scale demands. The final version of a Starship space station would probably not feel like the future at first. It would hum. Fans moving air that cannot stop moving. Pumps pushing water that has passed through bodies before. Radiators glowing silently outside. Computers watching pressure, temperature, carbon dioxide battery levels, docking ports, and the invisible chemistry of survival. From the observation deck, Earth would look effortless. Clouds turning over oceans, cities glowing on the night side, storms curling across continents with a scale no human system can match. Below, everything that keeps people alive happens without design. Air gravity, weather rivers, soil, sunlight. The ancient infrastructure of a planet. Above it, inside the station, survival would be engineered second by second. That is the real meaning of building a Starship station. It is not simply a larger room in orbit. It is a test of whether human ambition can become disciplined enough to live where nothing is provided. Starship may make the structure possible. Robotics may make construction easier. Reusability may reduce the price. But none of that removes the central truth. Space does not become gentle because access becomes cheaper. It only becomes reachable. And when the first crew floats through that wide steel volume, past the tank's wires, filters, laboratories, sleeping quarters, and windows, they will not be entering a dream. They will be entering a machine that must keep proving every minute that it deserves their trust. A rocket can reach orbit in minutes. A station has to survive there for years. And somewhere above Earth, moving faster than sound can travel. Humanity may learn that the hardest part of leaving the planet is not escaping gravity. It is replacing everything gravity once gave us for free.